Okay guys, so in this video let's talk about two important conditions called as stack overflow and stack underflow. Okay, so stack overflow and stack underflow, you might have heard about the wonderful website Stack Overflow. It's a good portal actually, but here let's talk about the technical descriptions. Stack overflow and stack underflow, very important terms. So as far as stacks are considered, there are three most important terminologies called as push, then pop and top, right? So top is a variable which points to the top element, push is something when you insert, and pop is something when you remove. Okay, so these three are the basic terms that you must know when you talk about stacks. Other than these, you have two important conditions in stacks. One is stack overflow and stack underflow. Okay, and a stack overflow condition means that the stack is full and you can't push any elements into it. Okay, the stack is already full and you can't push any element into that. If that is the case, then you have to say that the stack is overflowed, or this condition is called as stack overflow. Okay, the stack is full and you can't push anything. So whenever you are implementing the push algorithm, you have to check this condition whether the stack is overflow or not. Okay, if the stack is overflow, then you can't insert any element, guys. You can't push any element to it. That's the meaning of it. The stack is underflow, which means that the stack is empty and you can't pop anything from it. Okay, pop means removal, right? So you can't remove anything from it. The stack is empty. Okay, so that's the meaning of stack underflow. Okay, let's take an example, guys. Okay, so let's say this is my stack. Okay, let me go for some other example. I'll say 1000, I'll say 100, 200, 300, guys. So I pushed 100, 200 and 300, guys. Okay, so I'll write the algorithm like this: push 100, 200, then 300. Okay, so the last element which I have pushed will be the top element in the stack, guys. Okay, super. And always have the T, it's a good practice. Okay, the top. Okay, the stack will not exist without this top. I told you that so many times. Okay, so after that, let me say I want to push one more element, guys. 400. Is it possible? Of course it is possible. There isn't one empty element here, so I'll say 400. And okay, I'm sorry, guys, my top will now point to 400, right? So yeah, okay, so I want to push one more element, guys, say 500. Is it possible now? Okay, it is not possible, right? Because the stack is already full, and this condition is called as stack overflow. Okay, so if this condition occurs and the user is still wishing us to push 500, means you have to print a condition called as stack overflow, and you can't insert any elements to it. That's the concept of stack overflow, guys. And let me say I want to pop elements now. Okay, I had 400, right? So let me have 400, let me pop it properly. Okay, I'll call the pop function 1. I told you that you should not pass 400 here. It is not correct. Whenever I call the pop function, it means that I have to remove the top element, because that's the only possible case, right? You can only remove the top element. Okay, so call pop once, it will remove 400. Okay, then call pop again, it will remove 300, because now top points to 300, guys. Okay, so now what is the status of top variable? I have removed 300 also, so it will point to 200. Now I'll call pop once again. It will now remove 200 also. Okay, 200 will also be removed, and yeah, now top will point to the last element, guys. And if I call pop once again, then it will remove that element also. Okay, so now top will become -1. Okay, because the stack is empty, so top will become -1 because it's not having any value to point, right? So top will now become -1. I told you initial value of top is -1. Of course, when the stack is empty, the value again becomes -1. Okay, now if I call the pop again, observe that if I call pop again, is it possible to remove any element from the stack? Because the stack is already empty, we have removed all the elements, so it is not possible to remove any other elements. So therefore this condition is called as underflow condition. Okay, stack underflow. Okay, and this condition can be easily checked by checking whether t equals to -1. If top variable equals to -1, this means that the stack is empty, right? Then you can easily print that the stack is underflow. What I'm trying to say is you can just write a condition like this: if top equals t equals to -1, then you can print a message, printf a message stack underflow. Okay, so this is the message I wish to tell. So okay, we'll implement this algorithm in the next video. In the very next video we'll try to implement this push and pop, and I'll also tell you how to create a stack first. Okay, thanks a lot.